Alright, there we go. There's some audio now. Let's take a look at this. Testing 1, 2, 3. Alright, just so we know what we got going on, we're gonna do some, these will be our, thermostats. So let's put, 3 stats here. There we go. Like that. Just gonna connect them in. This will be to our PLC here. So what we're doing is we are designing a system for zoned cooling, so each room can kind of have their own heating and cooling area. And what is cool about this is we can take this and one room can be cold and the rest of the place can be warm. You have a guest over, they can have the room to be what they want it to be, and you don't have to worry if they want the place cold or warm, because you can sleep in your place with whatever temperature, they can sleep in their room with whatever temperature, no problem. So I'm just gonna doing an overview so we see what's going on here. Just this down to 20. Move it over there like that. Okay. It's just like this here. Paste it. We want this. No, it doesn't. Paste that. Stat. Paste it again. Get another stat. So these are for each room. And after this, so these are just gonna be to PLC in a, let's say, let's put this system in the, just draw a line here. Let's just say, so room 1, room 2, room 3. And then we're going to take we need relays for each room because each of these rooms have baseboard heat. So what we're gonna do is take some fun. Let's see. Okay, we'll just do this relay. Actually, is there something else I can do this? And do I have fuck, let's just do some AutoCAD. It'll be easier. I don't know why I was doing it in Paint. Boom. Can I do snap, please? Thank you. 0.5, thank you. Oh no, like whack these like that. Let's do 0.25 for snap. Rectangle. Here we go. So we got one stat. I think I just want 2, 3. Let's throw some more down. Cause let's do 5 stats total. Or 7 do I have? 1, 2, 3, 4, 5, 6, 7. Yeah, it'll be 7. Alright, there we go. You're kidding me, right? That's really how the label's gonna be. There we go. Oh, we'll remove that line 2. Remove leader, thank you. Okay. That center looks centered. Alright. Let's go. These. Looking good, alright. One row with 7 of them, and I'll just get 5. Okay. Actually, where's my where's my space mouse at? I'll set that up for next time we do this. So I got some stats. One for each room. I'm gonna do a PLC down here. No, not what I want. Want this with a label. let's go. Yes, thank you. Oh no. Should be able to. I'll leave it for now. Understand. Not what I want. Line. No. Thank you. Like that. If we could just move this over a little bit. Wait, did I lose my snap? I lost my snap. Snap, thank you. And this base point. Oh, we were already in the middle. We just need to move it over the other way. That a little bit. You really gotta be careful with these lines because if you overlap them, they're always a pain. Come on. There we go. Make this a little cleaner. Whack that. Pull this over here. This over that, and then we can, holy crap, no, move down. Okay, these aren't even snapped right. Oh, I'm gonna snap, whatever. Alright, here we go. A little bigger, so this looks nicer. Okay, let's see if we can. Oh, here we go. Horizontal land. Annotate, no. Just oh wait, no leader. There we go. There's the easy way of doing it. Interesting. That has a look here. Okay, PLC. But when I select these, I'll be able to group these together. There we go. Okay. And if we just ungroup these, whack on here, turn off the leader. I like now centered. Okay. So what we're gonna have is we're gonna have each stat for each zone going here, and these stats will actually be powered off of a power supply. It has to be external because we need the RC, the Y, and G. I believe Y is for hey, what's up? Man, for some reason, bot ain't saying anything. Oh, we're just working on some fun HVAC stuff, making a zone cooling solution. Don't know where code's at. So these stats will have how many wires? One, two, bundle of three. Alright, let's annotate this. Alright, we're gonna text 5 first corner. Alright, typical RCC. I think it's what is it, like RC YRG. Okay, yeah, it's so it's RG RCR GRCY. I'm gonna G. And what's heat? Let's look what heat is. Fucking pull up freaking internet. Thermostat wire code. Yeah, it's the Nest. Yeah, cool. Oh, green's fan? Okay, green's fan. Blue is for a heat pump. I could use it as an emergency signal, actually. Okay. So it'll be, Y is what? Cooling. We got G, which is, what's G for? Fan. We got our RC, which is our, common. Uh-huh. I think it's like RG, which is our hot, our plus 20 volts, or 24 volts. What's up? Y1, Y2 for stage 1, stage 2. Y1, C, and RC, and R. What the heck? Why did I have it listed? Oh, hey, what's up, Brandon? Unlike code, I don't fully understand what all you do. I wish I did. Now see here, they just label as R, not RG or whatever. Oh, it's just R, okay. Oh my god. These colors matter. Yeah, see, RC, RG, RH. AC only system, double transformer systems. Okay, yellow, fan, yellow, white. Alright, let's go back to our AutoCAD. Heat. G is for fan, black 12 volt from transformer. Okay. Here we go, better one. That's not what I was looking for, but okay. This thing. No standard exists. That's wonderful. So documented in our thing. Yeah, see RC. G. Oh yeah, the Nest is interesting because I believe it bridges it internally. Or something. Oh yeah, it has a C for common, which is blue. Oh man, nerding is going, just getting started. So this will be plus 24 volts. Bam, heating, cooling. I think I can do emergency heat. Let me see, where's my audio at? Look at this. Okay, it's up all the way. I'm probably quiet. Let me turn that up. There we go. The W triggers that, Y equals that. Okay. Yep, this particular extension is responsible for playing 24 circuit, okay. The reverse, okay, this is if you have a heat pump, the O and B, we're not dealing with that. Second stage, Y2, cooling, 2 compressors, so this is W for heat, second stage heat. Extreme winter cold, yeah. Okay, E terminal for emergency heat, which occurs when the system runs completely in a second. Okay, we're gonna have to come back and color code these for our documentation, but yeah, we will just select this and fucking whack it here. Can I frame this? Give me a second. What are these for? Oh, there we go. Properties. Oh, annotate. Yes, please. Oh, wait, no. Text frame. Yes, please. There we go. Alright, a little text frame for us. We can do an annotation. Yes. You always gotta center justify these. Annotate. Now, so if we look here, we should have an annotation line. I don't see an annotation line at all. Alright, we got what's going on with this? Yeah, save that. Bam, bam. We do a, oh, this one has one, okay. This has freaking 2. Alright, we'll just do this then. We'll just copy. Oh, that's why you put a. There we go. Had a weird thing in there. There we go. And I want to put a leader in here. Oh, that's what I wanted. Boom. Yes. Let's copy that. Whatever. We're going, okay. Center. Oh, crap. Boom. Justify all this. just like that. Alright, let's get back here. Okay, select the bam bam. Delete that. Let's go select this. Can I? Let's put a frame around it. There we go. Let's move this. Let's point this to that real quick. That. Alright, so each of those will run to the PLC. That means we'll need. Oh, wait. Well, let's look at our PLC. Let's see if that actually does what we want. We might need to use terminal blocks. Let's go automate direct. Let's look at our products I got. Let's look at programmable controllers. We're using the Plus series. Let's look at our stackable I/O modules. Discrete. I don't know if they use. Oh, they use AC. Oh. Oh. What modules do I have? Let me check. Alright, we're good. I did AC with what I have. We should be good there. Let's see. Alright, I might have ordered the wrong shit, but let's not talk about that or think about that. So, we're just working on our overall diagram. Now I think, let's look at the, no, we have to look at AC. So we look at BAM, AC, and AC modules. We got two of them. Really? We got two of them? Oh, because we're not using relays. We have to use relays. These, actually, what voltage? What's the amperage of a, let's look at like Y, like amps. Wire. Amps. Let's look at what the Y, let's see, 24 volts. Cluster 8, yeah, what's the amperage on these? Let's ask the AI. Oh, you gotta be kidding me! I gotta log in. No, let me ask ChatGPT. Log it over here too. Okay. Let's understand. What is Y again? Does anyone remember? I don't remember. Doo-ba-doo-ba-doo. Isn't Y? Oh, it's in our document actually. Just look here. Y is for cooling. Calling for cooling. About can vary. So half an amp. So 100 to 500 milliamps for residential, which we're doing. What about the RN slash RC? Okay, 24 volts. Point. Oh, okay. So I don't think. Because I have a discrete relay here. Let me check. On here we can do 4 milliamps. So yeah, we're kind of out of spec. That's wonderful. That's freaking wonderful. But would it still work? I don't know. Do not know. Let's get a thermostat and wire it up. I'll be back. Alright, I'm back. I do not know how the electricity in these PLCs are working, is what I've learned. Oh, this is wonderful. Turn myself up a little bit more. There we go. Like that? Alright, there we go. Don't want to be too hot. Awesome. Oh, there you are, code. Oh, there you are. Oh, so I'm like measuring PLC voltages off of these input terminals. Let me show you. So like we got these funny cool looking blocks over here. I'm not using relays, I'm using discrete input. And if you look at the specifications for these, what does this see? These are output modules, discrete voltage, input, yeah, one of these. This is all the magic. And I'm still learning how this works. Like you would think that like your output down here would actually be powering it. I don't know. Turn the knob. Oh, rip it off. There we go. Now I'm spiking. Now I'm peaking. There we go. Oh wait. There we go. A lot better now. Okay. I think. I don't know. Might be my Linux box. I don't freaking know. No, something is actually dynamically fucking with my audio. There we go. All right. Wonderful. So, let's look up the part I have. Got a combo part over here. So if we look at boom, 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 discrete, we're looking for DC here. Looking for, what part is this? Hey, hey, hey.
Can you hear me?
Oh, I hear you. Do you hear me?
Yes.
All right, cool. Yeah, the little meter in Restream doesn't act like a real VU meter.
No, it just lets you know that this is where you're at, and then it just kind of fades off
Yeah,
whenever it
yeah,
decides.
I'm using it for signaling, and I'm like leveling, and I'm like, this doesn't work for leveling. This doesn't work for
No,
leveling.
put your level at 100 on this thing.
Oh, okay.
Yeah, just leave this thing at 0
That's
or
what I
100,
did.
whatever it
Yeah.
is. Because you're. Oh, wow. It's me that's causing you to spike.
No, I'm my box is lighting up, telling me I'm peaking.
So, are you just trying to measure voltage on the PLC?
So no, so what I'm trying to do is let me look up my part number real quick. So I'm using this combo part right here. So if we look at the specs,
Bring it up
this
a
is the
little bit.
one. Yeah. So I'm measuring between like C and V. But if you look down here, I think they're actually isolated. Yeah, they're so all these are actually isolated from the PLC. Doesn't provide power to this. I have to power from an external power supply.
Yes, sir. You just saw it. They're
Yeah.
you're opto isolated on PLCs.
Yeah, and I just learned that thermostats are on AC, not DC.
Oh, so what was your DC voltage reading on your AC?
Well, no, a thermostat's not hooked up because I'm smart about it. So yeah, so I have to get. I'm not even like one of the last parts is actually designing the electrical enclosure. First part is researching and discovery, overall plans, and then you just get deeper and deeper with the sculpture, more detailed. But I think I have to use relays because these amperage readings on these discretes aren't actually made for thermostats. I'm literally 0.1 millivolt over, and just be running at that limit would have issues, I think.
And if you don't want to hear shit clicking, get solid state and just be done with it.
Yeah. Yeah. Where's my relay at? How you doing? All right, that's what our relays. Let's go with our AC versions. Two common, no suppression. Relay configuration. Oh man, I don't know what the hell any of this means.
Sorry, bro. Yeah, EJ, I'm sorry. I'm back and forth between this and the other thing I'm doing.
Oh, no problem, man. I'm using ChatGPT to answer my questions. What does this mean? What does that mean? I don't know what I'm doing. Oh, thank you. Alright, so relays would be output. I want to measure input. I want discrete number of inputs. Let's do 16 because I need a bunch. So that's the part we're looking at. That runs AC DC. Because I'm looking at like 7 stats or something total. And each of these are going to have 4 or 5 wires on them. 3 at least for signaling. Got to use a common bus for RC and plus 24 volts. No, I don't like this because they're all super isolated. Input module. What part is this? C016, 83, and 83. Alright, so these are just super isolated. So this is going to be a pain to wire when we get to the panel. Whenever that's the part we need for the thermostats. Alright, cool. do this.
So does this schematic actually tie straight into the PLC or?
No, this is just a block. This is a high level overview right now.
Okay,
This isn't using actually any of the electrical components.
10-4, 10-4. I was
Yeah.
just curious. I was like, I've seen some ladder logic done with visual, and I was looking at the name of it, and I was like, AutoCAD electrical. Well,
Well, yeah, I can do electrical stuff. I'm not there yet with the bomb and all that stuff. I'm
fair,
just using high level overview stuff. How do I
fair
break
enough,
an
fair enough.
array? Oh, you gotta be kidding me. Columns.
It's nice not being in the driver's seat.
Oh, really? That's good.
Hell yeah, man! I get to sit back and ask questions now.
Oh, okay. Ask away. I'm still trying to remember how to use AutoCAD. Array. Edit array. Source. replace, base point, row, comms, reset. Yeah, reset. Oh, there's options up top. Duh. Oh, let's go with like 3. Oh, you gotta be kidding me. What's it, like 1 point? Now measure here. Oh, that's 0.75.
Having to green mile another one right before getting off. Damn, bro.
Oh.
Dude had to fire somebody.
Oh, really? Okay.
That's like going and having a safety meeting way of saying that I had to fire somebody.
Yeah.
You know what I mean? So yeah, I'm getting my double fill.
Base point 0.75. Bro, the base point is right here. Five. Uh, bro, just
Hey, She Devil. Welcome.
Now I know why people use the actual other buttons on a space mouse. You know how annoying it is to hit L on the keyboard?
Yeah,
Yeah,
I
let me
do.
tell you.
I do. I really do. But I can tell you, you can't have too many fucking buttons on the side of the mouse.
No, you can't. Not when
Oh,
you're
yeah,
doing
you can.
repetitive stuff over and over again. Because you can
Oh,
have it
man.
change depending on what mode you're in. So if I'm in like one mode, it'll set the buttons a certain way, and then I could have a different mode for like electrical wiring and or if I have to modify block diagrams.
Yeah, my thumb can handle 6 buttons on the left. That's it.
Yeah, I'm used to AutoCAD. Wait, do I have right click? No, I don't have a right click wheel like I do in Inventor. Oh, are you kidding me? Yeah, I actually have to make a lot of components from scratch, which is not going to be fun when that comes. All right. Did that. Let's see. Let me see how big these are. Distance, side 1 inch. Oh, stop it. Uh, Thankfully, I know all the keyboard commands.
Shortcut keys are so nice.
Yeah, you don't really have those in here.
But
Yeah, you never really had shortcut keys in Inventor. Don't know why. Oh, do we miss one? Why are those red? I don't know. 1, 2. Oh yeah, we did miss a line. Whatever. Okay, that's good. Oh, that genius move right there. Move all of them at once.
I saw the genius move of the missing
Yeah, yeah, yeah.
one.
Yeah, I have no
But
idea what the
that's what I
freaking.
do, though. That's what I
Yeah,
do,
yeah,
though.
yeah,
Get
yeah,
them all, and then you just see that one that's just still sitting there.
yeah.
It's like, fine.
Oh, there's cleanup. Oh, wow. They actually now tell you where there's cleanup issues at. There's no cleanup issue there. What are you talking about? How to get rid of these red circles? Oh my god.
Sharpie eraser?
I know, right? Where's that tool at? Whatever. Let me go here. Edit source. Array. Edit source object in place. Select array. Yes, thank you. Now I can just add a text. Call this this is gonna be called uh baseboard relay. Okay. Uh oh. There we go. So there's our oh my gosh, there's a freaking OCD kicking in. Those red circles are gone though, so that's good. That's good for now. So this is going to be the one PLC. It's going to take all the stats in, take the baseboard relay, control the baseboard relays. Now we're going to do another PLC. Text. Yes, another PLC over here. I'll have a connection between the two. And this PLC will be connected to the HVAC.
What's up, Gregory? How are you? Dude, PLCs are like cash. You can just never have too much.
No, but what's nice is that once you do them, you don't have to really mess with them. They just keep doing their thing.
State machines are wonderful.
Yeah, oh, this is supposed to be HVAC. Whoa, get back here. There we go. Uh-huh.
Get you some trapezoid going on there,
I
bro.
know, right?
Nothing like a trapezoid to let you really know you're fucking shit up.
Mm-hmm. So we'll have all our stats and baseboards in this one PLC because all this will be located in the attic. So I'll have a PLC up there with all the wiring hooked up to that. And then I'll have the other PLC connected up to the HVAC.
Have you something to monitor the temperature up in the attic too?
Okay, yeah.
I mean, you'd be surprised how hot it gets, and even PLCs have an operating range.
Yeah.
You know what I mean? And you could do something on like a fucking ESP32, an ESP something, right, with the fucking thermometer on it.
Well, no, to be honest, if I can, the more I can run through a PLC, the more reliable we'll find it.
That's only true dependent on the code will run reliably. The reason I say that is because not you, but if anybody out there takes any skimp roads on this, wherever you took the skimp road is where your weak link is.
Yeah.
Right. Your PLC makes it run, will constantly check. It'll continuously run that set of
So it's
code.
from 32 degrees Fahrenheit to 131 Fahrenheit. So I'm gonna have to put like a heater in that thing.
Yeah, because it does get colder.
Yeah, unless it can keep itself warm. Okay, let me see. Yeah, I'll have to do some sort of temperature monitoring with it. Because I can actually do temperature monitoring with an analog input on these PLCs.
Yes, you can. Make sure you get the right thermocouple.
Yeah. Sensors and encoders.
Oh, how cute.
Temperature sensors,
I like
yeah.
it. I like it. Automation Direct. We'll just go through Walmart of automation. We'll take a little of this, a little of that. Let's get some cheese sauce over here. Mix it together. Ooh, look at that AC control unit. Ooh.
Yeah. Type. Oh, I don't even know what type of thermocouple I need. I think it's
Um,
ChatGPT.
I want to say, see,
To safely and accurately. Two important words. Oh my god, I gotta re-authenticate? What the hell? It's measuring K because it does negative 200 to 1372. But what about T and J? Listed ranges for all. Yeah, I'll be good with like almost any of these. No.
hey, unindoctrinated, how are you? And happy birthday, Doc, if I missed it.
All right. So temperature won't be that bad. Just not gonna draw a. Now I do also have a thermostat for the main house. Let's go with this. Uh, and this one will be connected down here like that. All right. Cool. Let's look at. So we got that done. That's the basic block diagram. Let's open up our thing. Let's see. Go to. See here. And No, I can't. There it is. Share. All right, let's take a look here. So this is our bypass mode. This is on our HVAC down. So let's see. One over here. Bypass mode X0. Fan, cooling, heat. Pass all that through. Actually, won't need to be passing heat through. Then we end that. Then call for cooling. And then if we go to our other stat, where's this one? Add one. What are we doing here? Oh, we're gonna have to build all these out. Oh, no. Yeah, I'm not gonna build all those rooms out right now. Let's go to here. We're gonna have to receive communications. Oh, I have to read a bunch of coils. Click addressing. Oh, this is gonna be X. Like, let's look at this one.
Pictures.
Yeah, so all
So
these
wire
are.
to here, wire to there. Tell it what it is. Tell it what it's looking
Yeah,
for.
I gotta
Ooh.
go. I gotta look up the part now I need for the PLC, cause I learned that it's all AC, not DC.
My bad. I guess I
What?
could have told you that, but you know.
Yeah, I'm just happy that they label it on the device. Like, oh, this thermostat's AC. Oh, in the data sheets. Discrete
Hook
input.
your security cameras to the power of your AC.
Oh yeah.
Please don't do that, but
No. Okay.
in a bunch,
Jeez.
you could run a 24-volt AC camera off of it and still have power to run the rest of the AC, I promise.
Yeah. So if we're running this, we need 1, 2, 3, 4. 4 times 7 is 20 something, 28. So we need
I will give
28.
you that as 28.
So if we have 16 inputs, we're gonna need 2 of these. So these are
Uh-huh.
so we need 2 of those for all the thermostats. We need an output controller for the relay. Actually, we need to look up that relay on Amazon. I don't know if I'm going with the Honeywell relay. So if you look up baseboard heat relay, this Abutech, which gets relabeled as Honeywell, looks to be a good brand. I'm just gonna have to get it from a supply house. Yeah. So if you let me search that. Come on, give me the spec sheet. Installation instructions.
Screw it down.
So yeah, I don't actually understand what these mean. Red, black, and blue. I'm gonna guess red's hot, black is ground, and blue is. We have to bridge these two to make it work. So like,
So if you look at it,
yeah.
you're switching L1.
Oh, that's what we're turning on and off. Okay, so black is what we're switching. Okay.
Right? See how L2,
Oh, okay. So blue is for load, black is for the other one, and red goes to the device. That color code doesn't make sense, but okay. I can't wait till I print all these out and make a giant binder full for documentation.
notice right there something that you might want to look at when you're looking at these relays. Go back up.
But
Must provide an overload protection and disconnect. So this
yeah,
thing has
I'm gonna
no.
yeah, I'm gonna do that in the panel.
Okay,
And
I'm
then
just.
wait a minute, I'm gonna be running high voltage in the panel. Oh, great! I can't. But they don't have that documented here. No, they just shove it right in here.
Yeah, they're just putting it in a box and hardwiring it in, and
Wouldn't that be a circuit breaker?
should be.
So I already have a circuit breaker for each of them. Does that count? But the circuit breaker I have is way higher than what they're wired for, which is I think another issue I have.
That means you know the higher the breaker, the longer it burns, bro.
Wait a second. Let me check. Yeah, mine are my baseboards. They have them, some of them hooked up as like a 200 breaker, and the breakers are 20 amps, but these only pull maximum of 4 amps. So whoever wired the place, I need to get those breakers swapped because that is way too high for the load.
Well, you got to remember the load itself also if all of them are going at the same time on
But
the same breaker.
no, they're on. There's only a maximum of
Individual.
2 of them on one breaker. Yeah, and I have 4 breakers, so that's a total of 8 amps. Let's round it off to 10 amps.
Fair.
I
Yeah,
can
a
get
5
like
wouldn't do it in that situation, but a 10 would have to.
yeah, because I would be maxing out. Yeah, I would probably want to put like a 10 amp adjustable breaker on there or something, like an industrial one, so you can tune it in. I live a whole different world professionally.
I work on computers by day.
I mean, I learned a lot of this from working at doing work for a machine shop.
Yeah,
BACnet, PLCs, this and that. Pick up a thing or two.
I just learned where the power switches were.
Yeah.
Where to stick my voltmeter in case I was looking for something.
hmm Okay, cool. So 3 wires. Yeah, here's the CWR common. Normally you have your would have your thermostat running off of this, but I'm gonna have these CWRs right to my PLC. Oh, there it tells you right here. And neutral, red goes to my load, black goes there, blue goes to my neutral too. Okay.
Yeah, you gotta have some way to induce that coil.
Yeah, that's what I mean. I'm gonna use the hook it up to the PLC.
Yeah.
What's the voltage required? What's the amperage required for that coil?
40 milliamp.
Where do you see that?
Last line control signal. 24 VAC, 40 milliamp, 1.2 VA.
Huh? Oh, right here.
Up higher
Oh,
too. So you got the FLA, the LRA, and the control signal.
oh yeah, I should have seen that. Oh, that's AC too. Okay.
Yeah, yeah.
All this stuff is AC. Wonderful.
Yeah, you shouldn't. It's not like a
24.
computer where you got to be
Yeah,
flipping back
I'm
and forth.
so used to digital that I need to get my mind out of that and design AC.
It might be a cheaper solution.
What?
Design it with AC.
Yeah, it probably is. Yeah. Well, digital does make sense too.
Well, yeah, I mean,
Well, digital is AC. Everything's well, not. I mean analog. Never mind.
uh,
All right.
analog.
So if you just measure out far enough decimal points, it's all analog. Get you one of those T2 meters with like 12, 24 points. I'd use one of those.
My needle is super sensitive on my analog.
Look, I had to measure superconductors. Do you know how many decimal points you need? And how many points over time? Like, there's
Dude,
like
look, check
2
this,
million
check this.
points.
You just talk to Fluke about it and go, look, bro, I got some weird ass measurements I want to take. And they go, okay, hold on, let me sharpen my pencil. And you go, I want to take measurements at like 30 below, right? And I got to be accurate within, I don't know, 10 to the negative 15, okay?
Have you
And
speak
they
to
go,
Keithley?
no.
You should start there.
Yeah, no, I play with Fluke, you know, that because I don't get that crazy.
Yeah. I'm lucky to play with the Rolls Royce in high school. All right, so that'll be AC. That's cool. Um, okay, cool. Let's see. AC, AC. All this is AC. Thermocouple. I'll be an analog. HVAC, stat, PLC. Cool. Then we get to let's go to our. Is this our attic one? This is our HVAC PLC. Let's look at our two of these. We're gonna need a AC output. Where's that at? Can I sort it in here? Oh, I can. Digital output. Let's just paint. I'm gonna need how many for those relays? Two times 7 is 14. Right? Yeah. Low voltage 3 wire, common, R and W is for heat, R is for the plus 24 volts. And I should be using a relay for this. Right? Oh no, I can use a discrete input. Okay. I think. Let me look. We want to do output module. VAC. I don't think I can do a discrete, can I? What's that? 0.3 amps. Get out of here, get out of here, get out of here. Yeah, I have to use a relay. All these are just over my limit. Alright, relay for the wind. Let's see.
They,
Outputs
do
would
you have a
be...
relay control pack or just
Yeah.
individuals with this thing? I haven't been on the page, so I don't know.
So we have... This is a... So there's two I can use here. We have this, which is a... Bam, and we have this. So this one shares the across 4. This one's all just is all isolated. This is actually what I'm looking for, I think. Right? What's this? Don't need that. So we need to bridge C and W basically. We don't need to worry about. No, we need to bridge W and R or C and R. One of the two. So this is what we need. This unit right here. 1, 2. So we get 4. I need 7. So I just need 2 of these modules.
I don't know if it responds fast enough.
What does?
When you request it to close the relay, it takes less than 15 milliseconds. I don't know if that's fast enough.
Well, thankfully, I don't have to do any high-speed counting of number 2 pencils.
Right?
They make special modules for that.
uh,
High-speed counting modules.
Indeed.
Yeah, dude, some of the stuff I've read online on like Reddit for the PLC Reddit
Yeah.
was interesting and very insightful of what people are dealing with. And you can learn so much from reading that stuff.
Dude, Reddit is a wealth of brain rot, comedy, knowledge, satire, evil.
Yeah.
I mean, it just it's a card catalog of just whatever you want.
Yeah. So we got our inputs for that. We got our outputs for our thermostats, for our relays, and then we need a analog. We need our analog. Not output module, analog, input module. Don't need that, don't need that, don't need that, don't need that. Sensors and encoders. Light switch. Inclination, linear, ultrasonic. Look at all these sensors. Holy crap, pressure. Where's my temperature?
Got a Pasig pressure. I mean, you got a Pasig gauge over there.
Digital temperature sensor. Thankfully, look at this. They got an overview page where you can easily look at this stuff, and they actually teach you on this site, which is very helpful. Temperature sensors. There we go. Temperature switches, digital temperature. Do we have analog? That'll be a thermocouple wire. Temperature transmitters, no. Temperature sensors, temperature transmitters with.
It might be a transducer. No,
Oh, what?
transducers measure pressure, right?
I don't know.
Thermocouples measure temperature.
Yeah, thermocouple, yeah.
That's what your temperature sensors would actually be under. It probably wouldn't call them thermocouples until you get lower.
Temperature monitor control with use of adjustments. I don't need switches. I need actual temperature sensors, temperature transmitter with integral sensor. No. Holy crap, dude! Look at all this. That's why I like this site.
Hold on.
Probes. Okay, type. Thermowells for highly accurate. No. Oh. Hex
We're good
nickel.
with one. We're good with 1 decimal point, guys.
Yeah.
I mean, and I think truthfully, unless we're doing Celsius, it's not really even needed.
Yeah.
Fahrenheit's so fucked up. I mean, oh my god.
Yeah. Cuttable probe. Oh, freaking no. Just give me one of these to look at, please. What the heck? Oh, this is a probe. Okay, that's. Oh, this is like what you'll stick in like a liquid or something. Nima, blah, 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 blah. I want to know what you are. Oh, you're just a probe. You're not actually. Oh my gosh. Okay, we're just gonna do this. Real parts. They make great content.
Look, and they want to stick it in something.
Exactly.
Nobody wants to measure open air shit.
No.
We got to stick our probe into something, and it's got to be able to be screwed into it. Type K is the most common, if I
Yeah.
remember correctly.
New junction not created.
Don't extend the cables on your thermocouple.
Yeah.
They're not speaker wires.
Yeah.
It's done by resistance, and if you make it longer, the resistance is more, and it'll read wrong.
No. No.
That's a That's how you don't blow yourself up with your damn hot water heater.
Yeah. All right,
Right?
let's go.
That goes
Yeah.
to the emergency off part of the ladder logic.
Yeah, stop everything. First thing. And throw all the error messages everywhere.
Yeah, everybody gets an error. Error for you, error for you, error for you, error for you. You know what this error is? This is stop every fucking thing error.
Mm-hmm. All right, we have 2 inputs.
I don't know. Because I'm not paying attention.
Are we measuring voltage or current with these thermocouples? Oh my god. Let me ask ChatGPT.
Usually it's voltage if I remember correctly.
Uh,
It's been a sec. Because Matt, I'm paying attention to a different stream and I'm just actually here for moral support on this one. Okay, I've modded
it's
everybody up.
voltage. It's voltage.
It is voltage. Wonderful.
So we need this 482.
Wonder why I'm hearing fucking repeats. God damn it. Got the fucking TrueTube channel, the YouTube channel open.
Alright, where's my analog input 482? What are these? Oh, these are thermocouple inputs. Look at this. I found it.
Oh, all you gotta do is tell it what type.
Yeah, and the module. Holy crap, look at this. You just tell it like K type,
Oh
K type.
yeah, just give
Tell
me
it what
some
data register
data.
to put it into.
Oh yeah, just give me
Alright,
some
well,
data.
one channel, please. Data register. That's fine.
It has to have a data register if you're gonna put it
Yeah.
somewhere. You know, it's not okay to leave it without a data register.
So
Remember how
run
about
mode
that
will be delayed.
redundancy of shit working, right?
Run
It's
mode will
not
be
okay.
delayed by about 5 seconds after power up because of the thermocouple module. Oh
Yep.
no. Now what's
That
cool
means
is you
it's
yeah, I can actually set the initial values on these in that time period. So if I go to like yeah, I think if I
set that to be the last one to fire up then.
nah. So if I go like here, if I set up require output oh wait, so if we go to our address picker, you have this initial value here. If we go to help, remember the help menu? Remember how applications used to have help and how useful they were?
Used to.
Yeah, used to. Maybe they still do. I don't know.
When it's designed by an engineer that knows that it's better that you know everything than not know everything, it's
Yeah,
good.
yeah,
It's
yeah.
good documentation.
Yeah, so if we go to initial value, it allows you to set the initial value that the CPU automatically sets after power up. So that 5 seconds, I can automatically set what certain bits are in that 5 seconds.
Are you sure?
Yeah, because it says after initial power up, not. I don't know. I can always test it, but whatever.
I would highly recommend
Test it
because
out.
it's different on. So like Alan Bradley,
Yeah.
If I remember right, what my dad was telling me, it requires you to wait. So you would fire that one up. You would either fire that one up first and then use it to trigger everything else afterwards,
Okay.
or right, use a couple of its outputs to turn the rest of them on.
Mm-hmm.
Right, so everything else comes on afterwards, or you run it separately of everything else and use inputs to control both.
Yeah.
Use the old digital ones and zeros, man.
Yeah. So
Most you need is 2 bits.
today I went to Home Depot and got all the things I needed. I got fish tape, thermostat wire,
Nice.
uh, circuit breaker locator, voltage detecting stick, um, a voltmeter thing because I didn't have one of
Nice.
those. I know.
Did you get one that reads amperage, AC amperage?
Yes, of course.
Good job. Good job. I just,
It's a Klein. It has to.
well, you you run amperage differently, right? You never mind.
Yeah.
I
Yeah.
I
This one
apologize.
this one only does up to 10 amps. I don't need anything crazy.
10 amps, huh?
Yeah. That's quite a bit. Cool. I guess I can conclude it here then. All right. I'm done for tonight then. I'm going to conclude the stream. Wish everyone a
Uh,
great rest of their night.
Y'all have a good one.